Good morning, everybody. It's so good to have us this morning for the pre-training class ahead of the coming training we are having for the month of August. And I'm sure we would all be, richly educated at the end of today's pre-class. So we just have about an hour to quickly run through some basic things we believe we all need to know for us to gain a full understanding of what will be done in the next month. So by now, I believe we should have opened our studio. So we'll quickly run through what we have for today. I'm going to share my screen and we'll get to see what we actually have prepared for today, the brief thing we have prepared. It is tagged pre-training on our basics for beginners. From all of us that have registered online, this training is just for those of us probably that are new to R or don't understand much on what we need to put in place as far as regression is concerned. So we'll be talking about the brief history of R. We'll be talking about variable. We'll be talking about indexing. We'll talk about a function. Thereafter, we'll talk about how we can set our working directory, and we'll do a basic introduction to regression. I hope that is okay. Is that clear? All right. Now, since we all have opened our RStudio, can we just proceed to what we have earmarked for today? I'm going to share the screen again. So when you open your RStudio, basically this is what you're going to see. So you're going to see this beautiful environment, and an environment that you can now start exploring to carry out your data analysis. When you look at my environment, it might be quite different from what you have in yours. My color is quite different from the default color, which is white. So for you to do that, let's start with that. You can go to profile. If you're interested in changing, you can go to tools. From tools, you go to global options. You go to global options. So it's reading options. So from there, you can go to appearance, and whichever one you like, you can just start changing. I'm using Cobalt. If you like Cobalt too, you can start doing that. Or you go back to the default one, which is that one you have when you first installed the software. So then when you're okay with any color you like, you can just click apply and you will see the effect on the environment. Then you can click OK. All right. So at the initial stage, when you open the software, you're just going to see these TV panes. The first pane will be for that of console, where you can easily switch to terminal and jobs. The other pane will be for environment, where you can also switch to history, connections. And the last pane will be for files, plot, packages, help, and viewer. Now, by default, this particular statement you are seeing on the console will come with it. So for you to clear this default statement, all you need to do is to press on your keyboard Control L. So Control L is to clear all these default statements. As you can see, all those statements are all cleared. So for what we'll be doing today, we would have to bring in the new pane, and that pane is where we can write our code. That pane is called the editor pane. So it's just gonna come here. You see the arrow script, you click on it. The shortcut could also be Ctrl+Shift+N. So when you do that, the pane is turned to 4. So then you can start writing your code there. Basically, we can, like what I used to tell my students, that we can use R as a basic calculator. I can easily say 2 times 2. Probably you want to do some simple multiplication. You can say 2 times 2. And for you to run the line of code, you see run here, or you see the alternative, which is control enter. So let's get used to control enter. I'm going to say control enter, and the answer will be displayed here on the console as 4. I hope you get that. So I've prepared to make this thing very easy because I want us to work within an hour. I've prepared a slide that we're going to use for today's training, the script for today's training, and you can do that if you have I'm going to send this script to you. And when I send it to you, for you to open the script, this is the same procedure you have to follow. You go to File, you say open file, and thereafter you search for the script. So I save the script with the name pre-class script. So just click on it and you say open. So just as I have told us from the slide that shows us about the outline that we'll be doing today, I said we're going to talk about first a brief history to R, and just for those of us that are new to R, it's a programming language and a software environment where we perform for data analysis, graphic representation, and also for reporting. You know, R was developed by Rosie Hacker and Robert Gentleman at the University of Auckland in New Zealand, and it gained its first appearance. That was in the year 1993. So you could see, I mean, some of us are born by then. It gained its appearance that year, and thereafter it has been one of the most popular software we use for people use for data analysis. So one advantage of R is that you can download free online. So for you to download, let me just see if I can easily type here. If you are to download the R, the first one you can download this R Studio by just pressing www.rstudio.com. You see, you can visit this link to download R, and when you download, you can just move to the level of resources, and from there you can easily download the version I'm using right now, or the latest version, as the case may be. So we would quickly talk about variable, and here we'll be learning how we can assign variable, what is variable, how we can list the numbers of variables we have presently on our R environment, and how we can also delete variable, and how we can perform some other advanced operations on our variables. So variables are nothing but reserved locations. You know, I mean, the concept I use to use in defining what a variable is just like a container where you have like biscuits inside. So the big container is what we call the variable, and the biscuit that we have inside the container is they are the data. So variable is just like a location, like a house where we keep our data. So when you are interested in seeing the data, all you need to do on this particular environment is to call on the variable. So for instance, in this particular class now, I have like I know Okwe is with us, and I know Afolabi, Dr. James, my good friend, and I know Oshoba Tuize, and I call him Peter. So we have a lot of people that are connected right now. So, but for the benefit of every one of us, and for us to understand what we'll be doing today, I will just use 5 of us as an example. So I'm going to, like I did here, I created a variable and I called it class R. Now, the first way we can assign variable is by using the less than assignment operator. And this is what it means. Your variable name will be on the left-hand side, and you are just going to use the less than with an hyphen sign pointing to the data that you are storing. And now in this case, the data we are storing is Okwe, names of participants in the ongoing training, Okwe, Afolabi, Dr. James, Professor Shoba, and Peter. Now, because of the fact that we have more than one names, so you could see that there is a C that begins it, and we have the open bracket, and we'll close the bracket when we have included all the names that we want to store in the variable class R. So what we are doing there is what we call concatenation. We are combining all those names together into a vector. So that is why for us to do this, we use the vector function. So the C that you are seeing in front indicates the vector function. And we'll still talk about function before we close. And when you are dealing with any function, when you open the bracket after the C to connote a vector, then there is need for you to close the bracket at the end of the term. So like we have done, when I run this, you're going to see the result displayed on the console. Now, when you look, let's look at our console very well. This particular thing shows that this thing has been successfully programmed. And when you look at the greater than sign that we have underneath it, what it means, and you can see a kind of cursor blinking at the console. What it means is that, my guy, array is ready to take in another function. What you have programmed was successful. Array is ready to take in another code. So that is what that means. And when you come to this particular place where we have class, our global environment, you see, these have been stored on the environment, so that when you are calling this variable again, it could be easily found on the environment. So when you look at it, you see in the front of it, let me explain this. You see CHR, it means that the class of this particular thing is character. Now you could also see where we have the square bracket 1 to 5, and you see the names that we stored in the variable class R. So this means that we have character and we have numbers ranging from 1 to 5. So the position, this is just talking about the position. 1 belongs to Okwe, 2 for Afolabi, and the likes. So if you are to see the result of what you have programmed, if you are interested in seeing the data that is stored in the class R variable, all you need to do is to use the inbuilt function called print. So let me delete this and just do what I'm saying, and let me explain the concept for you. See, print. The moment you write print, because of the fact that we're using RF Studio, it will suggest to you different functions that goes with the word print. Now, this particular scenario, this particular phenomenon is called IntelliSense, and this is one beautiful thing about RF Studio. So you could just easily click on this, and when you look at in front, you see something like base. This is telling you that the print function is coming from the base package. So the base package by default is installed. It is installed by default. So you don't need to install the package base before you can have access to the function print. So all you need to do is just to click on it, and then we're interested in printing that variable because of the fact that the variable has been programmed successfully, and when you call it, mere pressing it, like this is what I'm saying, when you press class, it will also predict, it will also tell you that you already have this here, class R, and you can easily select your class R and you run or you press Ctrl Enter. So it will reveal to you the data that it is storing. So from there, we also want to learn how we can assign variable using the next assignment operator, which is the greater than. And this is very simple. For that of less than assignment operator, the variable name will be at the left-hand side while we have our data to the right-hand side. But in this case, where we were using the greater than assignment operator, the variable name will be on the right-hand side, and we would have the greater than sign with the hyphen pointing to the data that is storing. And don't forget that we have more than one data, which is we're talking about the age of participants that are present in the class. The 5 ones I've selected, and the first person is 12, second person 14, and Dr. James is 18, Oshoba 17, and Peter 20. So we're going to combine them together into a vector. Now, having done that, you can run this, Control Enter. When you run that, you could see what I'm doing here. I use the function print to reveal the data that the variable age is storing, or you could easily just say age without using the function print, and it will give you the same result. Now, let's proceed and move to the last way in which you can assign variable, and that is using the very simple, the equals to sign. And we want to know the location where each and every one of us, each of these people that I've selected are connecting from. Now, I'm just going to name it location. You can type that, you can say location equals, you combine them together and you say, oh, I know Okwa is connecting from Edo. I know Afolabi is connecting from Lagos, Dr. James connecting from Ogun State, Oshoba connecting from Oyo, and I know Peter is connecting from Ogun State. So we have 2 people connecting with us from Ogun State. So you can run this, and for you to see the results, you can easily see the data that the particular thing is storing. So for now, when you look at this, we already have like 3 variables stored on our environment. So for you to see that, for you to know that the numbers of variables that we have, probably you want to create a new variable, and you don't want a situation where one is going to be overrating on the other. You don't want to write a new variable again. I'll be carrying the names of these existing 3 ones. So you can confirm by just using the function ls function. You can run that, and it will tell you that, oh, hello, you have 3 variables presently programmed on your environment, which is the age, the class R, and the location. So if you have to create another one again, you could easily use something different from these 3. Now, let me quickly talk about this to how you can, probably you are no longer interested in a particular variable that you have installed, or you make a mistake and you want to correct it. For instance, this location, I want to change Peter from Ogun State. I want to change it, I want to change it to a state like my state. I want to change it to a kitty state. So what I'm just going to do is I'm going to say rm, the rm function, and the argument that will be inside the function will be location. I'll say location, and then I will run it. So when I run it, by immediately you would see that the variable used to be 3 here, it will turn to 2. So now if I run location again, it will tell me that object location unfound because it has been deleted. So right now I can easily come back to this line of code and change this to what? AKT, and run this same line of code again. Now it will be programmed, and I can, for me to see the result, I can just press location without even using the print function. So that settles the next outline that we have, that is the aspect of a variable. And quickly I'm going to talk about function. I'm going to talk about function. I need to also tell us this. When you look at all these things I separated, that is coming out with blue, it shows that they are comments. So for us to have comment on R, we just include the arch sign. For instance, I'm talking about function now. I'm going to write function. Yes. So that settles that. Now, briefly we'll be talking about just few functions: the arrow bind function, the sim bind function, and the function for data frame. In the previous examples, we have talked about the RM function, the LS function, and we have talked about the vector function with the sign C. Now, we have two types of function. We have the inbuilt function, and we have the user-defined function. I'm just going to create an example of a user-defined function, probably the one that is just going to take the sum. No, we already have sum. I'm looking for the one that will take the sum of every of the data set that we have and divide them by 2. So I'm just going to say this function, I'm going to call it div. I'm just going to say div. I don't think there's any inbuilt function that is that is having that name. I'm going to say, or let me say Diva, just to be sure that there is no function inbuilt that has that name. So I'm going to say Diva. I'm going to say Diva is a function. This is not the time for me to talk about function. Maybe subsequent videos we can talk about function. I'm going to say Diva is a function, and I'm going to say, okay, put in data sets, take in data sets, and I'm going to bring in this curly bracket, and I'm going to, inside this curly bracket, I'm going to say, okay, I'm now going to put in the instruction. I'm going to put the instruction, the body of the function will be inside there. So I don't want it to be much. Normally I could easily split it down this way and put the body. I can say, this is what you do for me. Take the sum of data sets. Now sum, it's an inbuilt function. Sum data sets, take the sum of data sets. Now divide them by, I'm interested in dividing them by 2. So then I'm done with the body of the function. I can say return, or no, don't, maybe subsequent time I'll talk about the return function. So I can just run everything this way, Control Enter, and I already have it here as a function. That's at the level of global environment. So for instance, the data set we're talking of, let's use age. Age is like a data set that has like 12, 14, 18, 17, and 20. So if you are to, let's do that and just say Diva, so is a function, and we want it to act on age. So I'm going to run it. So it's just going to say sum of this data set divided by 2. So it's going to take the sum of the data sets, everything, adding 12 plus 14 plus 18 plus 17 plus 20, and you divide it by 2. The final answer is going to give us 40.5. So for you to know the sum, that means the sum could easily be known by saying 40.5 times 2. So when you run it, that tells you that the sum of that particular, the sum of the whole data set is 81. When you divide 81 by 2, you get 40.5. I hope you get that. So briefly, let's go to, that is an example of user-defined function. You can create series of functions. It depends on the kind of analysis you are doing. And let's move to the user-defined functions. These are functions that are created by Arrow core development teams. It wasn't created by me, and not created by any other person. It was created. It came with this particular software by default. So an example that we'll need is for now is arrow bind, C bind, and the data frame. What we mean by arrow bind means row bind. And this is what it means. You can bind variables together. Variables, this is the condition. The variables that you have to bind together must be of the same length. These variables must be of the same length. And for us to be sure that they're of the same length, you can use the length function. You say length, it's an inbuilt function. You say length to confirm. You say, what's the length of class R? Class R is down, so you can scroll down. You click on it. It will tell you that the length is 5. You can confirm again, of which these are what we know. But in case you are dealing with large data sets, I can say length of age. I can run st5, and at the same time, I can say length. I can say length of location. I can run it. So they are all of the same length, 5. So then I can go ahead with this arrow bind. So let me give a little space. Let me still remove this. Let me remove that result. Now I can say arrow bind. Then the arguments that will be inside will be those variables of the same length, which are class R, age, and location. So I can easily run this, Ctrl Enter. When I run this is what I mean by row bind. So it's going to bind them by row. These variables, all of them will be piled up in a row. So you can easily tell that Okwe, the age of Okwe is 12 and is connecting with us from Edo State. Afolabi 14 and Lagos. So this is just the way. You can just be looking down like this, Dr. James 18 Ogun State. Now that's about arrow bind. Now, if you're interested in printing this particular result again, this result displayed on the console, instead of rewriting this whole bunch of code, all you need to do is you can store it. You can store this whole code in a single variable, and that variable is what we call result. You can call it any name. I call it result here, and you can use any assignment operator. I'm using less than. So when I run it now, everything that you are seeing here has been stored. Don't forget the concept of variable and data that I explained earlier. So it has been stored now into the variable called result. So if you're interested in seeing this same result, you can just say result and it will give you the same thing. Now we just press arrow bind, class R, age, and location. I hope you get that. So let's move away and talk about C bind. C bind, just for us to know the difference between row bind and column bind. So you can just say C bind, class R, age, and location. You separate them by comma. You separate each of these arguments by comma. Then you run it. So you can see that this one is quite different. So now each of those variables are taking different columns. They are arranged by columns. So that's what we mean by column binding. So class R has the names of all the 5 people I've selected that are connected at the moment with us in this pre-class. And we have the age, their ages, and we have the location they are calling. So I know that now Prof. Oshoba is age 17 and is connecting with us from Oyo State. So I hope we get the difference between row bind now and C bind. Okay, good. Now let's quickly talk about data frame. Let's talk about data frame. Now, we will need this particular data frame in most of our analysis because we'll need because this is just like the best way we can represent table on R is by using the data frame function. All the tables that you have on your Excel, the best way you can interpret them, the best way you can write them in R is by using the data frame function. So for instance, I want to turn it into a data frame so that the class will no longer be a matrix or an array as it is for the ones we have done using cbind. For instance, if you check, this is what I'm saying, check the class, we already have the variable result to be storing the effect of arrow bind on those 3 variables. So I'm going to say class of results. So you could see that the class of this is matrix and array. And most times, if you are working on R and you have it in this particular form, for the kind of analysis we'll be doing now, we would have to change it from matrix and array. We'll have to change it to a data frame. Now we'll still learn on how to change it to data frame, but let's learn on how we can develop a data frame example, an example using data frame. So what we could do is we will say, let's create another variable. I said result2, and I said I'm using the equals to sign, and I said this is data. It's a data dot frame. That is, it's a data frame and it's coming from the base package. Don't forget, you can easily click this and you put in the argument, which is still the same thing as those variables, class R, comma, you say age, comma, and you say location. Good. So when you run it, very simple. Result2 has been programmed again as a data. You understand? You can see the data here by just clicking on this blue arrow. It will come up, to pop up somewhere. Okay, it is it. This is it. Somewhere here, you could see. So we know that class R, we have character for the class of class R. We have the class of age as numeric, and we have the class of location also as what? As character. So you can easily close it back again. Now, having done that, so if I now say class, to know the class of result2, we'll see that it is a data frame. The class is that of a data frame. So if you're interested in changing this one, I mean normal class, which is of the class, normal result, the result that would is storing the effect of arrow bind on the three variables. If you're interested in changing the class from matrix or array back to data frame, all you just need to do is very simple. Just say, you know, I still want to save the result of this transformation inside the variable result. I don't want to change the name of that variable. So I'll say result is assigned to as dot data dot frame. So it will suggest that for me, and I will say result. Then I will run this. So now the class have changed. So easily for me to know maybe the class have changed or not, I can say class of result. You know, normally this class of result, the answer will give us a matrix or an array. I can say class result and I run it. So the class has been changed successfully back to a data frame. Now let's learn this the concept of indexing, which is an important concept in what we'll be learning. Well, what other resource persons will be teaching us, including myself, because I will also be there to learn. You know, what they will be teaching us in the coming months. This concept of indexing is very important. So for instance, we're going to deal with class R. Indexing means you're interested in a particular observation, you understand? Out of many observations, you're interested in a particular observation or a set of observations in a large observation. So you'll be dealing with their position. For instance, I'm interested now in Afolabi. So all I need to do is to index Afolabi with respect to the variable name that Afolabi is stored in, which is class R, and now use the position. Afolabi is in position 2. So when I'll be doing that, all I need to do is, first of all, call out the variable that Afolabi is stored inside, and now say, okay, now I know we have 5 names in this variable, but I'm interested in the names in the name in position 2, which is Afolabi. So you use the square bracket when we're dealing with indexing. So I can easily say run. I can say run, and there we go. We have Afolabi. So let's take, for instance, that we are to develop a model, and in that, in developing that model, we have like 100 data sets, and you want to use 70% of the data sets to, develop your model, while you use the rest 30% to test the efficacy of your model. So all you need to do is you have to divide those data sets into 2, and you can do that by using the concept of indexing. All right. There are other ways in which you can do that. There are other ways. It depends on whoever is writing the code. There are other ways, but I just want us to understand this concept of indexing and do an example under regression. So we have now, I'm interested, I want to create a variable and I want to call it train data. Maybe I'm interested in using the observations in position 1 to 3. Why I want to use the rest from position 4 to 5 to test the model I've built. So it will be very simple. I'll say this is the variable I want to create, the new variable I want to create, and I will call it train data. I'm using the less than assignment operator, and I want to index from variable class R observations that range from 1 to 3. That's what this line of code means. Then I run it. So train data have been programmed successfully, and then test data, just I'm interested in the remaining 4 to 5 observations. So I run these two. So if I run my train data to see what it has the first 3 names as it is written in that line of code. And for the test data, if I run the test data, it will also tell me. I hope you understand this concept. All right, that's good. Thank you for your feedback. Now, we would now need to talk about how we can set our working directory. I think we're still working with time. We need to talk about how we can set our working directory. I'm just going to teach us like 2 ways to go about this. The first way would be by using code. Now, by default, our working directory on now is set to documents. So for you to know that, you can use this function coming from the base package, get wd. So it's a function. You can just write get wd and you run it, control enter. When you run it, you would see that this particular R is the default working directory is set to documents. So, and most times the data set you want to read, because now we'll be learning how to import data. Let me also note that importing data importing. So now we know that our default working directory is a document. For instance, like the data set I want to bring in now for the purpose of this example is student performance. Student performance, and is a data set on 1,000 number of students in the United States. Did you get that? So now let me stop this and show you where the data set is. Let me share another screen. Let me share my screen again. Let me share. Okay, I have this. I hope you can see my screen. Okay, good. So it's a document, it's a GIS database, and I have it as arrow test. Am I sure? Yeah, arrow test, and I have it at data sets. You could see that I have moved beyond the folder document. I have gone like 3 folders more: GIS database, arrow test, and data sets. And this is the example. This is the data set I want to read. This data set is an Excel file, but it is not, the extension is not with an SLS like the Excel extension. This one has an exceptional extension, which is the CSV extension, comma separated variables values. Now, let me open it. Let me open it so that we can see. Let me open it with my Excel. Open with Excel. I want us to get what I'm saying, because most times when you are performing your analysis, you would have to input your data in Excel, and from Excel you can take it. You can also take it as a table. You can take it. You can even read normal Excel file without this CSV extension into R. All these are possible now, but let's learn how to do that of CSV for the purpose of this class. Now, this is the data set that I'm interested in. I just want to get, my interest is just to get the mean of reading score, which is one of the variable in this particular data set. So you could see we have gender, we have just 2 gender, male and female, in this particular data set. So I hope you're following what I'm doing. I'm going to close this now, since we all know that it has an extension of CSV. I'm not saving this, and we are back. So this is what I'm interested in reading now to R before I go ahead with my analysis. This is the data set that I need. And now I want us to pay attention to this. By default, it was set to document. Now I have to redirect it to data sets. And how do I do it? I will have to move from documents to GIS database. You have to write it. R is case sensitive. So you have to write it the way you save it. Like in my own case, my GIS is in capital letter. The database has D as capital letter and B as also capital letter. We have arrow test, arrow capital and T capital, and we have data sets. I hope you are following. So let me stop this screen and go back. Let's stop and go back to where we stopped with our RStudio. Now I want to set this working directory now I would say I'll use another function again from the base package. I'll say set work directory. Please pay attention. I'll say directory is equals to, I'll copy what I have on my console, that is the default directory. I'll paste it here. Control V. Thereafter, I will now start, directing from document to GIS database to arrows test, and thereafter to data sets. So how do we do that? Because of the fact that these are character, that's why you see it in quotes. Don't forget, when you're writing anything that has to do with character, it must always be in quote, except for probably the logical class. For instance, we have true or false, so you could leave that without it being quoted, because Arrow will understand that you are dealing with logic. Now, but in this case, you have to quote all this whole thing. So for you to direct it from document to GIS database, all you just need to do is to include the /. Then you say GIS database. Don't forget the D capital, the B capital. Then I move and I say arrow test. Wrong. And I say arrow test. Thereafter I move again and I say sets. Then I run it. So now it has been successfully programmed. So if you go back and run this get work directory again, it will not give you documents. It will give you the new one that we have. I hope we get that. Okay, good. So for instance, I'm interested again in setting it back to document or any other thing. The shortcut is just go to section, go to set working directory, go to choose directory, and thereafter any other place you want. This is what we are using now. You can change it back to GIS database, you can change it back to document, and then you click open, as the case may be. So we're interested now in how to import that data set that we have. The name of the data set is student performance, and it is spelled with capital letter S for students and capital letter P for performance. So you have to write it the same way it is. Then I want to give it a new name here. I want to give that data set student performance with the extension CSV. I want to give it a new name. I want to call it data. So we have something called data. I want to call it let's call it a name. I want to call it datum. Let me call it datum. And I said datum is now the function we use in reading CSV extension files is the read.csv. Read.csv function. Okay, from the util package. Thereafter, you can now impute the name that you save that CSV extension with in the dataset folder. Now, in this case, now it is students performance.csv. So you are going to quote it because it is a character. So I'm going to say students P in capital letter performance.csv. So having done this, all I need to do is to run it. Now, when you look at the aspect of data, we have datum. You can click on it. You can click to review. It will tell you more information about it. And if you click on this, if you click on it this way, you will see an example of the data set we are talking of. So we have gender. This is the same thing we opened on SD the other time. So we have gender, race, ethnicity, parental level of education, launch, etc. So my interest is I just want to calculate the mean score, the mean of the math score. That's my interest. So I'm going to close this. You can just click here. You will see the result to come up in a new sheet for you. And then I can easily close this. So now I said I just want to do, before we move, I want to get, my interest is just to get the mean of the math score. Don't forget the math score is a column under the student performance data sets, which is now bearing the datum name on R. So I would say I'm interested in seeing, okay, let me say I'm interested in seeing those names, the names of the columns, you can use the names function, NAMES, you open bracket, and you say datum. You run it, so it will tell you the names of the column we have. The first column is gender, second race, ethnicity, third parental level of education, etc. So the math score I'm interested in is in the 6th column. So let's say for us to have access to the 6th column, this is what you do. You could say you make reference to this datum and you use the $sign. You say datum and you use the $sign. I hope you are getting that. You use the $sign and you usually come and you say math score. You select math score. So it will only give you results for math score alone. And this is what we have here. So for what I'm interested in the main. So all I need to do is to say main is an inbuilt function from the base package. I'll say main, datum, and I'll use the $sign and I'll say math score. Then I run it. So the main of the math score is 66.089. So I'm sure we get that. Any question? All right. Okay. At the end of the class, we'll take questions. Okay. So let's move to the concept of regression. And the data set we'll be using, the free data set we'll be using just for practice is the trees data set. You can just say trees, just press trees, all the small letters trees, and you run it. So it will tell you to bring this result for you. Trees, measured observations on get, height, and volume. Maybe because I like tree, sorry, that's why I'm using this example. But if you are interested in checking for other data sets that you can use in practice, you can use the library help equals data set. You can run this and you see numerous examples of data set that you can use to practice. So you see it will come up with a documentation for the package, and you can see we have Nile, we have low lowly, etc. We have tooth growth, we have US arrest, etc. And then this is the tree data set we are dealing with now. Where's tree? Guy, where are you? Yes, okay, these trees. And it is diameter, height, and volume for black cherry trees. So if you're interested in using any of this, you can just press Swiss. If you're interested, for instance, you're interested in using Swiss, you can press Swiss. Or women, Arrow would know by default that you're dealing with the default data set that came with that particular package. Okay. So the first thing we do when we are dealing with regression is we would first of all need to understand the relationship. We need to see the relationship that exists between these variables that we want to carry out regression on. Do you understand? So for us to see that relationship, we need to use the plot function. The plot function is what we will use in getting the scattered diagram for two variables. So if you look at my code, you see that I am still referencing when I need height, I want to see the relationship that exists between height and volume. And you see that I still, when I'm calling my height, this is what I'm saying. Let me say plot. And I'm interested in doing the plot of height. Don't forget height is a column under tree, and I'm separating with comma with volume. When I do this, it's definitely going to give me error because there is no object like height found and no object like volume to find because none of it is programmed on a global environment. All we just know is trees. And all we know again is that this particular height and volume are sub-observations under the trees data set. So if you want to see this relationship, all you need to do is to call this with respect to tree. Call those height and volume with respect to trees by using this same thing and the $sign. So you see trees, you see height, and you see trees, and you see volume. So you run, and you would see this particular relationship. If you're interested in seeing more about this relationship, you can just click on Zoom, and you would see more. And you can just look at this relationship. Is this relationship linear or non-linear? To an extent, it's linear. So let's just quickly fit a linear regression equation for this particular thing. So again, I just want us to understand this. There is something we call attached function. So that this attached function will help us, instead of just calling height and volume with respect to trees, you can just call them easily by just saying plot, height, trees, and volume. Do we get that? So attach mean it would, by default, it will be doing these trees dollars for you. So when you run this, it saves you the stress of writing $3 before you call your height and volume. So for instance, you can say plot height and volume. Like, okay, we've done height before. Let's just say we have get, so that we can see the effect of that attached. We have get, and let's say I want to see the relationship between get and volume. Definitely, you see, it's going to be different. So the attach, you see, it's also like a linear one. We could say that the attach function have saved us the stress of calling trees at every time we need height, volume, or get. All right. So another thing I think we would also need to understand is this the concept of using the regression sign. In this case, when we're dealing with this, what this means is that we're saying plot, open bracket, x, the variable on the x-axis, we want on the x-axis, and the variable on the y-axis. That's when we're using the comma. We're using comma. But in this case, when we are using plot and we're saying volume regressed with height, then what would be for volume? This volume, thereafter, we are talking about volume as the dependent variable. Volume, dependent variable, and the height is the independent variable. That is to tell you that for you to get the volume, you will definitely need records on the height observation. That is what we are trying to say in that regard. So you can plot, it's just going to give you the same thing that we have before, using this same concept of S and Y. But please, let's try and get this very well. This is the dependent variable would be on the left-hand side, regressed with the independent variable. So this particular sign is what we use for regression. And how do you get this sign? All very simple. When you look at your keyboard, you will see the button below the escape key and beside number 1. So you just hold shift and you press that button to give you that regression sign. So let's quickly fit a linear regression model with this particular example that we have. We want to predict volume using height. Don't forget, this is what regression means. And it's also one of the machine learning techniques. You understand? You have an observed measured observations, and you want to use the machine to predict, to mimic, and to learn that particular relationship that exists between volume and height, or height and volume, as the case may be. Now, in this case, we already have the observed value for volume and the observed value for height. I don't know how they arrived at volume. Maybe there is a formula that they used in getting volume, and that will be the case. You understand? For those that are in forestry, we know that there are some formulas that you can use in getting your volume, the Huber's, the Smolyan, and the Newton's formula. So you can apply that to get your volume, and that is what is going on here. But now we want a machine that don't even know. Maybe they use Smolyan, Huber's, or Newton's formula. He doesn't know any of these formula that they use, but he can easily predict it. He can easily predict that, that kind of relationship that is existing between these two variables. So that is what we're about to do now using the regression concept and the linear regression model. So for you to perform anything on linear regression, all you just need to do is to say LM, you put what we have on the dependent variable on the left-hand side, regressed with the independent variable, then you separate with comma. Then which data set are you using? You say data equals, we're using the trace data set. Then this is as simple as ABC. Then you run and you'll be waiting to see your result. So this is your result. You might not really understand this result now. This is telling you that this is our what? This is our coefficient, and this is what? The parameter for the height. You understand? That's the coefficient of the height for this particular linear model. Now, just as we have dealt with the concept of variable and data, now I want to save this result in a variable. I want to save it in a variable, and I want to call that variable model. That's what I'm doing in line 94. So I'm just going to say model. The only difference is that I'm just assigning a variable called model using the equals to assignment operator. So I run this, and thereafter, if I click on model, it will still give me that same thing. I hope you get what I'm doing here. Okay, now you can get the summary of the model. This is another function, the summary function. Just press summary, and you can see more information about that model. So you can see if we are to judge if the model is efficient or not. You can see the multiple arrow squared. You can see the residual standard error, you know, and you can see the arrow square. You could see that this is very low. You can see the F statistics on 1 and 29 degree of freedom. You can see, etc., etc. The p-value. You see, so the p-value looks very small, smaller than 0.005. The cutout value for significance, but the arrow square value is telling us something. So I might not be talking much on this particular fit analysis to judge the efficacy of our model, but let's just look at what we have. Let's just talk about the concept of residuals and the coefficients. So because of the fact that we know that no model can be 100% efficient, so we know there is definitely going to be room for error. So the error is what is known as our residuals. So for this particular thing now, the result that we have here, the model already have a whole lot of things. For you to know some of the other things that we have attached to the model, you just press model and you say $sign. So you can see that the models by default, when we run this particular line code 94, line of code in 94, we would see that by default all these things would have been attached to it. The coefficient, the residuals, effect, rank, fitted values, assign this, etc., etc., etc. So if you're interested in the fitted values, that is the value that the model have predicted, you can just say fitted value, then you run it. So this is what it means. That is, you know, the observed value, this is now talking about the predicted volume, the volume that the model has predicted for us. If you see, when you look at that of the observed, let's move up a bit to see the observed value for volume for the first measured. It is 10.3, but you could see what our model is predicting. The model is predicting 20.91087, which is like over prediction. This is an example of over prediction. So for us to see, let's see. I want us to compare. Let's get some information about the residuals. That's what we'll be doing with line code 103. I want to create a table so that we can be seeing what I'm trying to explain. I'm going to call the variable resid info, that is some information about residual. And I'm going to store it in a data frame, in a table. And I'll say the observed volume. This is the observed volume, the measured volume. And I will say comma. I want to place it by the side of the fitted value, which is the predicted value for the volume. That you can get by using model $sign fitted.values, comma. Then I want to know the difference, which is the error. And I want to know how big the margin of error is and how small it is. So I will say open bracket to be sure, because I want to perform a minus operation, subtraction operation. I'll say volume minus the observed volume minus the fitted value. So when I run this, then I can come to, not to waste our time, I can just click here and I can read. So the observed volume is 10.3, model is predicting 20.91. So it is, there will be an error of this. So this is 10.3, it is predicting 13, at least a minor error. 10.2, it gives like a good prediction, fair prediction here. This is 16, is giving 23. 18, 37, abnormal prediction. 19, 40, wow, so abnormal. 15, 14, a little bit okay, So this is what this particular, this is what the model has predicted, and we can see what our residuals is talking of. So what you see in this particular result, when you're talking about residuals, are analysis carried on this particular third column. The analysis carried on the third column. So if, for instance, let me go back to this particular script and tell you what I'm saying. Okay, now let's say I'm assigning error as volume minus observed volume minus the fitted value. And when I run this, I would get something. And for me to see error, I can easily say error is already saved as a variable. I can click and see, etc. 1 to 31 variable. So to see the summary of error, which will definitely correlate with what we have in the result, you see the same thing. The only difference is what we have here as the mean 0. The rest correlates with what we have in this particular column row for residual. So this concept of intercept, this is what it means. Let me see, maybe let me stop this share and quickly explain the concept of intercept before I close and join the other meeting I have. I'm going to close this now and I'm going to share like my whiteboard marker. This is what I mean. Let me go back before I do that. Let me be sure I know the value of the intercept. Okay, 87.1, 1.54, 87.1 and 1.54. I'll stop and I'll share a new one. My white marker board, share. So this is it. For instance, this is what this linear regression equation is telling us. I have A plus B ish. So here our Y stands for our volume, A stands for the intercept, and this stands for the parameter for height. You understand? That's the parameter for height. Now, what this means is I'm going to say volume. If I'm to write the fitted regression equation now, I'm going to say minus 87. If I'm right, minus 87.1 plus 1.54 height. So with this particular regression equation now, you can easily know your volume as long as you have your height. So this is what we have successfully done. This is what we have successfully fitted. And I think we understand this very well. Let me still go back to our studio and see maybe we could do one or two things. Do we have any question? Okay, no question. So by the grace of God, I'm going to share this script to our mails. And if there are any questions, you can mail me. This is my mail. Or impact at Yahoo. Thank you. All right. I wish us all a blessed day. So as regard the coming training, I can assure you it's going to be massive. It's going to be great. Honestly, those that will be coming are like intelligent people, that kind of people, intelligent people and good teachers. So myself, I will be connecting live. I'll be connecting live. I won't miss any of those sections. I'm sure you won't too. Thank you. All right. Goodbye, everybody.